We could do most of this on Desmos, and should do okay. All right. All right. So does everyone find the page? Top right says graphing and TI calculator. Okay. So it says using the write the equation through the 2 points. So again, we worked that one out. Agree? But just for fun, let's go to Desmos. Make sure we're good with this. And I want to make sure everyone knows where to find these things. All right. So Desmos, graphing calculator. So if I give you 2 points, you know, because you had excellent geometry teachers at some point that said 2 points defines the line. And then in algebra, we found the slope, then we found the point slope, blah, 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 blah. But help me out. Remind me, if you recall, how would I plug those 2 points in to get the equation without having to do any pencil paper work? Anyone recall on Desmos how we do that? Yeah.
Y1, and then the little
tilde,
and mx plus b.
mx1 plus b. Okay, that's going to be the second step. Yeah, you're absolutely right. How do I plot the points though? Yeah, I'm going to hit this upper plus button, and I have to do a table. And then I'm going to do 2 and 6. 2 and 6. And then -4 and 3. And then it gives you those 2 points. We'll make them darker. Okay, so I think you are all comfortable enough in math knowing that there's exactly one line that would go through those 2 points. Agree? And then we're going to go down one row, and we're going to go y1. And the reason we're choosing y1 is because look at the label of my table. It's x1, y1. Now, if you start doing multiple tables, this will change to x2 and y2, x3 and y3, so on and so forth. So that's where you would start changing this. And then we use the little tilde. Anyone find the tilde on their screen? I think it's under alpha, underneath, between the B and the N, below that. So that tilde, we don't want to use equals, because equals is the algebra portion of it. Tilde is the operating system for Desmos to say, I now know I have to find an equation. So I'm going to go mx1 and then plus b. And then that'll give me my line of best fit, where m is 0.5, so that's my slope. B is my y-intercept, so my y-intercept's at 0, 5. But it'll do the math for you, which is a beautiful thing. Okay? Now, places where people might make errors on this. I would say it's probably on the second part, where it's the y1 tilde. You'll forget to put tilde, you put equals. You'll forget to go have the x1 and the y1 labeled as x1 and y1. Or sometimes your table, if you made another table, might come up as x2 and y2, which means you would make it y2 tilde mx2 plus b. Does that make sense how I stated that? So if I had multiple tables, I was trying, like let's say I was too lazy to hit the x to x out my data, and I do another table. You know, if I just hit, hey, I want to do another table, take a look at what that table is. It's x2 and y2, which means I would have to change x1 and y1 to x2 and y2. So there's just a few places where there might be an operating problem that you didn't realize that you had to do, and that happens. And again, if you get stuck on something, you guys know you can ask me. All right. So help me out, because I don't remember. So I'm as bright as a keyhole and as sharp as a marble. Let that sink in for a minute. You know, keyholes aren't bright. Marbles aren't sharp. It's a little sarcasm for syrup. So look at number 2. Did I do number 2 with you guys at all? No. We didn't talk about it? Okay. So let's talk about number 2. So I'm going to get rid of these 2 things. I don't need these, or these 3 things. And I'm going to go ahead and plot y equals, so I'm going to go y equals x raised to the third, and you use the a to the b to get the 3, then you have to make sure you bring it down, minus 2x raised to the second, minus 6x, and minus 5. Okay? And if this goes away, there's things that you can see. For the most part, you're seeing all the entirety of the graph. Doesn't have any other turning points on this graph. So they want us to say, find all the key points. The intercepts, well, I have an intercept here. Agree? And I also have an intercept there. Okay, one of them happens to be the x-intercept. One of them happens to be the y-intercept. Does that make sense? Do you agree with what I have so far? So 3.879, comma 0 is the x-intercept. 0, comma negative 5 is the y-intercept. And most of you probably know this, but for those who don't, when you have a long string of stuff and you have a constant, meaning a number that doesn't have an x attached to it, so in this case it's negative 5, that's why our y-intercept is negative 5. Okay? I know that some of you are like, I know that, but some of you might be like, oh my gosh, that happens? Yeah. Okay, so then other things, I'm going to get rid of those values. It also says find the max and the min. So, and this is called the relative max. It's where it turns from our slope of our line was positive. It became 0 because it topped out, and then it starts going down. So we have a max. So we have a max that happens at this point. A lot of times the max is only the y value. Okay? So watch how the question's being asked. Like if I had this as multiple choice, I would not have this as a point. I would have my max at negative 1.949. Okay? I use the y value to talk about the max. But then I also have a minimum. The minimum means if I had figured out what the slope was, as I came all the way down this, it was all negative, and then it gets to a point here where it starts becoming positive. So as it's going down and then it's going up, that's called a relative min. So my min at this point is happening in the x direction at 2.23, but at negative 17.236. So again, if this was multiple choice and it said, what is the min, I would have the number negative 17.236 listed. Is everybody okay? So max is a top turning point, and a min is a bottom turning point. They call them relative maxes and mins because the absolute max and the absolute min is negative infinity because our line's going down forever. To the left and to the right, it's going up forever. So our absolute max is infinity. But we had a couple turning points that took place on this graph. Okay. Friends, taking a look at this problem. Do you see any asymptotes that might take place? Now, before you answer, look at the original problem. Do I have a denominator? If the answer is yes, is any part of the denominator a letter, an x? And the answer is no. So I don't really have an asymptote. Other places you might come across an asymptote is if you start seeing stranger symbols, like you see a big square root. It doesn't really mean an asymptote, but it could. Okay, and I put that could as a disclaimer. But if we take a look at number 3, using the knowledge I just told you, do you feel number 3 could have an asymptote based on what I just said? Yeah, I believe I'm going to have an asymptote because my denominator has an x in it. Does that make sense? So for problem number 3, in our book on graphing and TI calculator, you just go y equals 3x divided by x minus 2. And you got to make sure that x minus 2 all stays downstairs, which it did. And we actually have something called a vertical asymptote, and we also have something called a horizontal asymptote. Okay. The vertical asymptote is taking place here. Okay? The horizontal asymptote is taking place here. Okay, so there's two things. There's one other type of asymptote that they might call a slant asymptote. They might call an end behavior asymptote. And that's basically where our line is approaching as you go off forever in the x direction or forever in the y direction. Okay. So let's zoom in on this a little bit, see if we can just use a little bit of logic. So vertical, up and down. You with me so far? What x value do you feel that that would be at? So we're talking about this vertical line. What x value does it appear that it would go right through? How much? Anybody? We're talking about a vertical asymptote.
0.
0? 0 is right here. So x value. On the 2. Okay, so now let's think about this for a second. An asymptote is something called an undefined value of a graph. Okay? Why would that 2 create an asymptote? Look at your x values. What would the 2 do if I plugged it into our problem? Yeah. Yeah. If I plug 2 in, on top I get 3 times 2, which is 6. You're like, yay! But on bottom I get 2 minus 2, which is 0. And 0 underneath is undefined. And how I always remember that is underneath, and I said it's in algebra 1, underneath and undefined both start with a U. The things that allow me to realize how math works. So if I wanted to, and the nice thing about Desmos is it allows me to graph x values. So do you feel that that blue line I just put in there, do you feel that that's a pretty good representation of our asymptote? Okay? So as I get really, really, really close to 2, from the negative side, as I get closer and closer and closer to 2 over here, the smaller and smaller and smaller my y value becomes. It becomes more and more and more negative. Now, if I come this way, if I come from the right side, and I said, as I'm approaching that asymptote from this side, where does it appear that my y value would be? What's way up there? Infinity. So as I approach this way, I go to infinity. As I approach this way, I go to negative infinity. Let me pause. Does that make sense how I just stated that? Okay. Now there's one other asymptote that does take place, and it's our horizontal asymptote. So we have to kind of think about, okay, there's a horizontal line in here in which my graph won't cross. And if you recall back to Algebra 2, there was basically 3 different situations to create a horizontal asymptote. So the first one is if the degree on top and the degree on bottom are equal. Well, the degree on top, I have 3x to the first. On bottom, I have x to the first. If they're the same, then the lead coefficient, 3 over 1, or 3, would be my horizontal asymptote, okay, which is right here. So let's take a look. Could we decipher that? Does that make sense if I say, well, y equals 3? Does that appear to be a nice asymptote for us horizontally? Absolutely. Now, the other rules are if the degree on top is greater than the degree on bottom, then your asymptote happens at the x-axis. Okay, so it's y equals 0. And then the third rule is if my, let me take that back. If my degree on top is smaller than my degree on bottom, y equals 0. If my degree on top is bigger than my degree on bottom, you don't have a horizontal asymptote. You have something called an end behavior or a slant asymptote. We'll talk about that a little bit more. Okay, we doing okay? Can I move on? Again, if there's terms that we use that are goofy, let me know. Problem number 4, we've already done this type of problem. Will Desmos do that problem for us very nicely? Or, yeah, I mean, type it in as it sits there. Can I get rid of those? Anyone still deciphering what those mean? All right, let's get those out. So I'm going to go x squared minus 2x is minus 15 is less than or equal to 0. Okay, so that if I picked any x value in that purple region, any x value within that purple region means that we would, if we plugged one of those numbers in, our value to our equation would be a negative number. Okay, less than 0 is negative numbers. So our values, our critical values, basically are -3 and 5. So if I took -3 and plugged it in here, I'd get 0. If I plugged 5 into here for x, I would also get 0. So this is going to be one that if we wanted to figure out what our domain would be, I'm going to go square bracket -3, comma, to 5, and then close. Okay, that's my domain. Now, ignore the fact that it says 2-element list, but that's what our domain would be in this case. Why are they square brackets and not rounded?
Because it's a solid line.
Because it's a solid line. We have an equal sign that's part of the inequality as well. Do you agree with that? Yeah. Okay. So my hopes, I know a lot of you have seen a lot of this type of stuff before, but we're utilizing a different technology to kind of walk through it. I hope it's kind of like maybe backfilling some gaps you might have had, which it's okay to have gaps in math. I kind of love the fact that this class could, if you've seen this before, it might reinforce what you know. If you've never seen it before, it's a easier representation, in my opinion. All right. So for number 5, we want to know what the domain is. So I'm just going to go y equals, bless you, square root x squared minus 16. Okay, kind of a wild looking graph. It's not continuous. Do you agree with that term? Being I'd have to pick my pencil up to draw each side. So my domain on this one, the value going all the way this way is -infinity. So if I come from -infinity to -4, okay, soft bracket on both. Infinity always has a soft bracket or a parenthesis. This 4 also has a soft bracket because let me ask you this. If I plug -4 in here and I get -4 quantity squared, I get 16. Agree? 16 minus 16 is 0. Square root of 0 is 0. So this y value is actually 0. So is 0 positive or negative? 0 positive or negative? It's neither. It's the only signless number we have. Do you guys want to know where the number 0 came from? You really want to know? Any of my friends in here who are Hispanic heritage? Ancient Aztecs came up with the concept of nothingness. Before that, they didn't have it. I mean, the Romans, they had, I, BBI, X, BI, BBI, BIX. Aren't you glad that we don't live in that age? Hey, what's your number? It's BI, BBI, BBIX, XX, BBII, BBIIX. I'll just come to your house. I won't call. Okay, so my domain of this one goes from -infinity to -4, both with soft brackets. Then it starts back up again at 4, soft bracket, and goes to infinity. That's our domain. Okay, problem number 6. Before we graph number 6, do you think it has an asymptote? And if so, what sticks out to say that we're going to have an asymptote on number 6? Oh, there's 2 number 6s. I'm sorry. The first number 6. We can't number in math. Denominator has a x. Yes. Excuse me. So the very first, number 6, I'm going to go y equals, and then I'll put this in parentheses because it kind of gets goofy. X minus 3, close parenthesis, divided by x plus 1. So definitely, we have two asymptotes. We have a vertical and we have a horizontal. But we're just trying to label the domain. Okay, so the domain is going to come from negative infinity and get to, or approach 1, or negative 1. Okay? And then on this one, it's going to go from negative 1 to infinity. Both with soft brackets. The reason it's soft brackets is we can't get to negative 1 from the left or from the right. It becomes an undefined term. And then number 6, I think I already worked this one out. The second number 6, because we have, if we're trying to find the intersection of those two, I'm going to set the left side equal to 0, and then the y, or equal to y, and then the right side equal to it. So I'm going to do this. And then my other one, I'm going to go y equals. And I have to go search for my absolute value. Oh, it's down there, right above the ABC. X plus 2. And then close that bracket. And minus 3. So where's the intersections taking place? The purple and the green. You just use the x value to label that. So negative 2.541 and 1.791. Those are my two intersections. Okay, so that nails that page, I hope. If you have other questions about it, please come ask me. But I want to give you the opportunity to get quite a bit of this done. So what I'd like to assign you is the graphing review number 1. And I think you can knock out all of it. I'll give you a lot of time to work on it. It looks like 1 through 13. Every now and then we give you some answers. Looks like we have a bunch of answers there, but we don't stay consistent. So you have the rest of the period to work on those and do well and make us proud. You have